Welcome back everyone to Litmus Test. Today we're talking about states of matter part 2. We're going to look at more advanced states of matter, what a state is, and what do we mean when we talk about a phase or a phase change. Last time I left you off with an interesting little puzzle to go home, look at some ice in your fridge, and you should notice that some of it has sublimed. It has changed from a solid into a gas, and the ice has gotten smaller. I left 2 ice chunks over here, they've disappeared. But what I really wanted to talk to you today was about the lava, because lava has 3 distinct and unusual behaviors in Minecraft. We saw last time that lava poured directly into water, or water that meets a source block of lava, will turn into obsidian. Lava allowed to flow into water will create stone. And if we have some flowing lava, and we allow water to meet it, we get the piece of obsidian, of course, but we also get cobblestone. All 3 of these are the same phase transition. They all represent freezing, something going from a liquid to a solid. But they aren't all the same result, are they? In Minecraft terms, stone, cobblestone, and obsidian are distinctly different. In real-world terms, these 3 substances might not be that different, but they might be, and their differences, well, it's kind of weird because all 3 of these should have the same chemical composition. They should all be made from the same stuff. They're all made from lava that froze into obsidian, cobblestone, or stone. So the difference then is not in whether the lava was moving or still, but in the real world the difference is how quickly it froze. And that results in 3 distinct phases. A phase, in this case, is a way of representing a substance in a particular state of matter that is distinctly different, has different physical and chemical, sometimes chemical, but distinctly different physical properties and structure from other phases, from other versions of itself in the same state. So all 3 of these are solid, but they have different properties. In the real world, we would talk about their density, whether some of these are heavier or lighter. So in the real world, we would expect the stone to be the most dense, and we'd expect the cobblestone to be the least dense. And the obsidian, well, the obsidian really depends. In real life, what we call cobblestone in Minecraft is called pumice, and this is actually very, very light. And people use it on their feet and stuff all the time. But it's light because it's full of lots of little air bubbles. This stuff froze so quickly the air didn't have time to escape, and so in Minecraft it looks cobbly, and in real life you see lots of bubbles. Obsidian is more like a glass than a rock, and the obsidian is, let's say, it takes us longer time to freeze than the stone. The stone is like, if we take this cobblestone and we organize it, you notice how the cobblestone, it's cobbly, it's broken up. It's what we get when we break stone. Stone is less broken. It is one whole piece. And in the real world, we can look at crystal structure. We can look at the way the atoms are arranged to form this piece of stone. And there's a particular structure to them. Now we'll cover crystal structure and the different types of those in a later video. It's interesting, but for now, point out that the structure of atoms, the way atoms build this, and the way groups of atoms cluster together to build a stone is different than in a cobblestone or in a glass like obsidian or just glass. And these are different phases. They're different state. They're all the same state of matter. They're all solid, and they're all the same stuff. They're all frozen lava, but they have different properties. In Minecraft, their properties are, well, if you break cobblestone, you get cobble. If you break stone, you get cobblestone. Different properties. If I put stone in the furnace, nothing happens, but I can put cobblestone in the furnace to get stone. Different properties. I can make portals to the, nether. I can make hell portals out of obsidian. It doesn't work with cobblestone or stone. So we already see that we have different properties in Minecraft, and these are not the same as properties in real life, but the idea is the same, that they are the same state of matter, of the same substance, but they have different properties, so we say they're different phases. We can do something similar for liquids and gases, although it's harder to see right away how liquids or gases could have different properties or different phases. And this is where the analogy kind of breaks down a little bit, because Minecraft doesn't have a very good depiction of this phase. But actually, this steam gets pretty close. So imagine if we take some gas and we pressurize it. If we squish the gas so that all of the atoms and the molecules of the gas are really close together, we can make it into a liquid. And this liquid, well, it's just like any other liquid. It's a liquid. It flows. But we can get it there by cooling the gas or just by squeezing the gas. But it turns out that, and this is where the steam is very interesting, oops, it turns out that in addition to, oh, that's a nifty little interaction there. Oh, look at that, squids. In addition to what we expect liquids and gases to do, this steam behaves like something that we call a supercritical fluid. And this is our first example of weird phases of matter. A supercritical fluid it's a fluid. It flows like this steam or like water does. And if we break the source block somewhere over here, it goes away. Get out of here. Ruining everything. Go. Shoo. Out of here. There we go. Okay. Back to what I was saying about steam. So steam is an interesting example because it's a very, very commonly used supercritical fluid. We see supercritical steam in pipes frequently. Supercritical fluids flow like fluids, but they are, like the steam, dense. They are kind of like liquids, even though they're also kind of like gases. They will expand to fill their shape. Notice how this spreads way far. And it also sits on top of this water as if it were less dense, which probably shouldn't, but yeah, that's okay. It should also have weird stuff going on at the edges. Supercritical fluids can only exist under high pressures and sometimes usually under high temperatures as well. We see supercritical steam a lot when we look at steam pipes. So places like buildings that are using steam for their heating system will have supercritical steam inside them, just as a nature of keeping all of that stuff at a really high pressure and a nice high temperature. We can see other types of weird states of matter in plasma. Plasma that we see like in your plasma screen TVs, well, nobody uses those anymore, but used to see in your plasma screen TVs, or more commonly like we see in fire. If this explodes, I'll be very happy, but it probably won't. Fire is a mixture of states, a gas and a plasma. A plasma is just a gas where all of the atomic bits have been separated. All of the electrons have come off of the protons, and they're just floating around in a free stream of ions. That's all. A plasma is technically a fluid. It flows and it moves, and you can see that in the way the flames move upwards. Yes, some of that is, animation and programming, but it reflects what fire does for real reasons. Fire flows and moves. And that's a plasma. Plasmas flow, they move. They are fluids. Plasmas take a lot of energy to form. You'll see plasmas frequently from lightning, fire. You'll see plasmas from certain interesting science experiments involving grapes and microwaves that you should look up before you try, and probably shouldn't try. There are plenty of other weird states of matter as well. Things like Bose-Einstein condensates, and strange different forms of ice, but all of them have the same idea. It's like this lava, a way of arranging the atoms such that the properties are different, even though it's all the same temperature. And we can convert between these phases, between these states, in phase transitions. Like we can freeze the lava into cobblestone or stone, and we can melt ice. We can, well, burn stuff to make a nice rosy campfire. We can, as the sun goes down, you can imagine that it's a giant flaming ball of gas and stuff. Well, that's just gravity compressing everything into a nice little plasma. We can get plasmas through lightning, and all of these are examples of phase transitions, ways of going from one state of matter to another. These are really important in engineering and in chemistry because there's a lot of interesting energy and math that is associated with this. It's very important for manufacturing, and it's very important for automobiles, cars, motors, etc. But for now, as the moon rises, let's just reflect back on the states of matter, like we said, different forms of atoms in the same substance, but with different properties. If you want examples around home, find some sand, and find some glass, and find some quartz. Each of these are the same idea, silicon dioxide. But sand and glass have very different properties than quartz. But they're all the same substance. They're just in different phases. So see if you can find some around home and examine them. And until next time, stay safe and don't catch on fire.